Okay, so as you can see here, we have the outline. I have not darkened the border nor the title box. It is a guide for me. The last stage would be to darken that. So I will start off with the main important point, which is to allocate an estimate, that is as well the horizontal and the vertical. Somewhere in between that layout, I am going to estimate the vertical and horizontal. So with the aid of your t-square, you draw horizontal. That is going to represent the horizontal axis, and we also do the vertical. We are estimating, we are not measuring, we're estimating just to get that there. Good. So we have the x and y axis. I move on now to get the 10 millimeter, and as shown before, I tend to use the draw the x to get a faster way of getting that 10 millimeter. I set a 10 millimeter below and a 10 millimeter above the x and y. With the aid of the t-square, draw horizontal. Wherever these two meet, the x here, these points, that is where we should now draw the vertical. And I prefer to use the 30-60. And as you can see, we simply need to provide an outline. I am not darkening. It is an outline, and I'm using construction lines. Okay, there we have the example. So now it says that the figure is an oblique hexagonal prism, so we need to start with the construction of the hexagon. So if you refer to the drawing has the front, the plan, and it has the end over here. Okay, the only difference compared to the ones you have done is that the front elevation that will be here is inclined, and before I get the front elevation, I need to start with the plan. So the information that I'm given is that the length of one side for that hexagon is 40 millimeters. So that means that the circle that I will use to draw the hexagon is 40 millimeters. So using the position here, this quadrant, that's first, second, and third quadrant, I will use this point of reference, and I will set 40, and I will set 40 millimeters below. Okay, to get a point here of reference, because I will draw horizontal and a vertical. The other option you have, you set your compass. This can be another alternative. You open your compass to 40 millimeters. Okay, and you set your compass here at this point and describe 40 and 40. Okay, and then you use your t-square and you draw construction line. This will be the center for the circle. So that is the center, and once I have located the center, now I need to use my 30-60 degrees set square. I am going to make this now my reference point, and I want to draw given that is, I want to draw the baseline. The baseline, as you know, is 40 millimeters. The complexity behind drawing the hexagon is very key for you to know, very easy to start with. So I will use I want to set off at this point using this is 60 degrees and this is 30. So from the center I want to set my compass here, sorry, my set square, and I will draw a line. As you can see, okay, I want one line. Once I've opted to get this line, then I use my compass using the same radius, which is 40. I set here at the center and I draw a circle, complete circle. Okay, and this point is one that is going to give me the first side of the hexagon. So I will draw now. That's the first side. Using the compass again, same radius of 40. I'll set here at that point. Scribe 1. I rotate the pencil and the compass, and I scribe here a second time. Same radius, I reposition here now, and I should get this point here. Okay, then same radius I will reposition now here at this end, and I'll scribe an arc above. Similar process, I move on to my right hand side at that point of intersection, and I scribe a second time. So I have 1, 2, 3, 4, 5, 6 points that should be used. I will then use construction lines to obtain the required hexagon. And the last way to not to darken, sir, but to join the top points. So this is the hexagon. So this is the plan. Now I need to draw the front elevation. How do I go about drawing the front? Well, all I need to do is to transfer 1, 2, 3, 4, 5, 6. I need to transfer this up by using vertical lines. So I use my t-square along with my set square. This point and this are aligned. I draw vertically. I take a look at this point here. They're aligned. I draw vertically. The technique is not putting too much pressure on the pencil, as you can appreciate. Okay, that is the given front elevation. And the height is it is an incline. So from here, this is the x and this is the y axis. So from here I will measure, I will set off 62 millimeters. So I use my ruler and I will set 62 millimeters, and I will then use my 60 degrees set square along with my t-square, and this 62 is where I want to draw a 60-degree angle. Okay, and then I want to draw a horizontal line at this 62. This portion represents the top of the prism. From here to here, we should have a distance of 70 millimeters. 70 millimeters is the height of the prism. Okay, but because it is inclined, then there is a slight effect on it. So what I do now, I need to project the same distances I obtain here to the top, and I want to set these same distances below. So I use my ruler and I have noticed that the first point, from the first line, that is the closest point is 20, then 40 millimeters, and then 20 millimeters. Once again, I am measuring that this is the top portion which is being represented here. So to set the bottom and complete the front elevation, I need to set off 20. Remember, this is the y-axis. 20, 40, and 20. So in a similar manner, I set off 20, 40, okay, and they're on 20. All right, to check that it is accurate, I can also use my set square. So what we do now, once I have obtained this, I transfer by sliding my set square to that point, and you will see that it coincides there. I move on to this third point, and last but not least, fourth point. So here I have my front elevation. My front elevation is from here to here, going up over this side and closing back to obtain the front elevation for the oblique hexagon. But I am not done there. I still need to obtain the other portion here for the hexagon. So what I do now, I want to slide and bring down these points first of all. So remember that point here is being represented here to the top. This and this is being represented by this point here to the top. This point and this bottom are being represented, they are aligned, but they're being represented here to the top. And this one is being represented here, being the end of that. So but what happens to these 2 points? These are 1, 2, 3, 4. These 4 are going to form the other portion of the of the plan elevation, given that it is inclined. So what we do now is we want to use and project this line just vertically downwards, the second point, the third point, and they're on the fourth point. Okay, so I know that it is a lot of lines, but you just need to follow the procedure. If you're getting a bit lost, then you can pause and then you can replay the respective section that you got slightly lost. So what we do now, given that this represents the front from here to here, I need to find this portion or this bottom section that will represent the plan view. So what I do, I project horizontally across the center as well, and the top. Again, I can start seeing the plan, sorry, taking shape. So this point, remember that this was the farthest, okay, the corner, that angle here. So the same thing will happen to the bottom. So this is being represented here. So this needs to be joined in a similar manner to like this to the top, which represents this. So here is this point, sorry, is being represented by this line. So which point here has to be brought down? So we obtain a point with this here. That's our point of reference, and if I follow to the bottom, this is another point of reference. Okay, I'm simply using the line being brought down from this point. So this must be joined with this and this to have one face or two sides of that hexagon or the bottom hexagon. I'm hoping you're not lost. We follow then this point to this, which is from here it moves and it touches that point. So similar to here, if you have a point here to the top, you need one to the bottom. So we follow that line and we have them meet, and that is the point. Okay, so I want to slightly join them first. You do not need to darken. So we have 1, 2, 3, 4. We need 2 more sides to get that hexagon, and to get that we follow this point that should be joined with the center. So I follow here and this top, that is the corner. So we have 2 hexagons, 2 the top, and then this will be the bottom. Okay, so that you don't get slightly confused, I will go ahead and I will darken the views so that we perhaps get a better understanding of what is the view. So let me darken. This is inclined to 60 degrees. And this is the top. Okay, so this is the prism, and then this is the plan. So let me darken first because you are seeing it from the top, this is what you will be able to see first, and then a portion from here it won't be able because it is inclined. So first I darken what I will be able to see. It is important that you clean your instruments before you start working. So I have the top being represented by this hexagon, and then the bottom being represented by the second hexagon. However, the second one you won't be able to see all. So what I will be able to see would only be the following. Please take note of it. So that is the hexagon, and then the other portion here is, which is this point here and the bottom, and then the center, which is here. Okay, this is broken line. The reason why it's broken, it's because these surfaces we won't be able to see because we're taking a look from it here from the top. There we go. That is the front plan, and now we need the end over here. And to get the end, let me darken the X and Y so that you get a better understanding. So as you note, I rotate my pencil so we have even wearing of the lead. Okay, so we have a very consistent line. So this is front plan. The end does not go here because this is third angle. So first you have your front, the plan, and then the end goes here to the top. So to get the end, I need first a 45-degree angle here. So I use my set square, and here I can project this line 45 degrees. See, I don't press too much on this so that I can get the effect of a construction line. Then all of these points I must project horizontally across, vertically, and then project these to get the end view. So project them to touch that horizontal, that 45 degrees, sorry, center lines. All of these are being represented by one line. There we go, 45, and then the end. There we go. To project, I project first this line vertically, center line, change this to square. There. So we have one line being projected, second line being projected, third line being projected up. So I need to project these points, and these are represented, all these points here are represented by one line across, and all of these points are represented by one line as well, and we have that line already drawn. So to obtain the end, to obtain the end is as follows. So I find this line, the center line, and the we have front plan end 5mm. Once I set here, I project across to get that 5mm. T-square is very convenient, very helpful. And as you see, construction lines. So we have the front, end, sorry, it should be plan view. My mistake. So this should be plan. So you should avoid doing the mistake I'm doing now. So you need to write neatly. Alright, plan, and then this becomes the end elevation. There we go, end elevation. Okay, all these must be within the 5mm guideline. And